the second one on this number 3 right here is, it's B. So it's H2S. Okay, so this is H2S. So first is the Lewis structure. So that's hydrogen, 2 hydrogens, and a sulfur. Put them like this. And hydrogen only has 1 electron, and sulfur has 16, or 6. It's going to have 6 electrons. It's group 16. So 1, 2, 3, 4, 5, 6. So you just join them, and they would just be joined a little bit, pushed in a little closer to the sulfur, so it would just look like that. So, now, for the geometry part of this, there's 2 connections to hydrogen, so it's going to be no, not hydrogen. There's two connections to sulfur, so it's going to be right here, and then there's just going to be a line to hydrogen and a line to the other hydrogen, and that's all it is. That is the bent version. It is bent. That looks like dent. Bent. So that's how you do that one. Okay. Now the next one is SiH4. So the dot notation will look like this. So there's a silicon and 4 hydrogens, all of which have 1 electron, and silicon will have 4. And then they will all join together like this. They will all join together like this. This is the dot for the I, by the way. That is how this will join together. Okay. Here in the middle, this one comes up, there's a hydrogen. Here is a hydrogen. Here is a hydrogen. And here is a hydrogen. So that is your geometry shape for that one. And it is tetrahedral, because it has 4. Okay? CCl4. So we got 1 carbon and 4 chlorines. Carbon has 4 electrons, so it's 1, 2, 3, 4, and chlorine has 7. 1, 2, 3, 4, 5, 6, 7, and then the same for all of these other 4. It'll look the same. So now for the carbon, we'll have 1, 2, 3, and 4. And then all of these will have 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. That is basically what it looks like. That's a little bit of a messy example, but that is basically what that looks like. It'll just be a little bit cleaner than that. And then for the geometry portion of it, it will look, it is also tetrahedral. So it is going to look like this. So you'll have carbon in the middle, and we'll go Cl, 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 and Cl. And that's what it looks like. There is your molecular geometry for C carbon, I don't know what that would be, but it's carbon and chlorine 4. This is a little bit complicated, but not too bad. So you're going to put carbon here, oxygen will be up here, and then the 2 hydrogens on this side. So hydrogen only has 1, oxygen has 6, and carbon has 4. Okay, so when you bond them together, they're going to bond here and here. And then they're going to bond right here. And you're pretty much going to rewrite it like this. So oxygen will still have its 6, carbon still has its 4, and the hydrogen will have the 1. And that is how you do the dot notation for this one. And then I will show the geometry. I think you were going to have carbon in the middle, and there's going to be a line, oxygen, and these 2 will be the hydrogen. These 2 are the hydrogen. Cl5. Okay, so that will be like this. We'll have the Sb, that is antimony, in the middle. And this will be Cl, 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 Cl. 1, 2, 3, 4, 5. And then, so if you chlorine has 7, so it's going to be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And that is really all you need, because antimony has 5. 1, 2, 3, 4, and 5 are already around it from bonding the chlorine. If you write it a little neater than I did. That is how you do that. Okay. And then you go like this. 1, chlorine, 2, chlorine, 3, chlorine, 4, chlorine, and 5, chlorine. And that's what it looks like. And that is your molecular geometry for that one. Is phosphorus and fluorine 3. Okay, so Okay, so it's gonna be like this. So you do 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and these two. So it's just gonna look like that. It's pretty simple. You could have done it way more easily than I did. It's pretty simple. So there's phosphorus in the middle, and then there's 1, 2, 3 fluorine coming off of it, so it is a pyramid geometry wise. So there's that one. CH2 Br2, the carbon here in the middle, and then you're going to put the 2 hydrogens here and the bromines like this, and then you're just going to do like this. 2, and then since hydrogen only has 1 electron, it's already bonded, and then everybody should have what they need there. So that's how you do that one, and then the geometry for that. Okay, the geometry for that will be like tetrahedral, I think, because then you will have, yeah, it's tetrahedral, so you'll have your carbon in the middle. You'll have here the bromine, here the bromine, here the, whoops, here the hydrogen, and here the hydrogen. So that is, it's the tetrahedral thing, shape. Okay, and the last one for this is I think it's ClCN. Cl, so we got chlorine, carbon, and nitrogen. 16 altogether. Carbon and chlorine. So put 2 here. 2, 1, 2. There's a triple bond right there. Here, here, and here. And that should give you 16. So there is your dot notation for linear. So you're going to put the chlorine here, then the carbon and the nitrogen, and it's just going to be like this, except there's a triple bond here. And that's what it looks like. That is your linear because it goes straight across. So this one is linear. Okay, I will do the next one in a minute. See you.